I was opening out the middle of a piece of stainless tube when the lathe just lost drive. It wasn't a heavy cut, I was only going from 7.5 bore up to 8mm. There was no clunk or crash, the chuck just slowed to a stop. The motor and belt seemed okay, and the end of the input shaft was still turning. The chuck was nice and free, which narrowed down the likely area of the problem. I had a hunch that one or both of the transfer gears inside the headstock had either sheared its keyway or lost some teeth. I've been here before, not with a lathe, this was uncharted territory, but with my mini-mill. This is a close cousin to the lathe, as the 2-speed gearbox and spindle arrangement are almost identical. The first thing I did was move the machine from its home to the trolley in the middle of the room, so I'd have free access from all angles. I started by removing the gearing from the end. Nothing looked out of the ordinary. I'd hoped, to preserve its alignment, that it might be possible to make a repair without removing the headstock from the bed, but at the same time I was mindful of not making a rod for my own back. I'd have nothing to lose in trying to remove the spindle in situ, and if it wasn't having it, I'd have to remove the headstock and possibly look for someone with a hydraulic press. I haven't got a puller, so I cobbled something together from the junk I had lying around. Although I didn't expect it would actually remove the spindle, I did hope it would give me an idea of just how tight everything was. As luck would have it, it came apart without too much difficulty. With the spindle out, I was reminded that one issue is that the holes in the end of the casting are smaller than the gears themselves, which means passing the spindles through the gearbox and threading the gears on from the inside. Something arguably best done with the gearbox removed, as this gives access through the open bottom. Now let me just say, because, even at this distance, I can clearly see pearls being clutched. Yes, the gears are plastic, but they've lasted 12 years and they're still in remarkably good condition. They're perfectly adequate for a small light-duty machine like this one. They're quiet, not needy for lubrication, and provide a weak link should anything go badly wrong. Metal replacements are available, but as it stands, there's no means to keep them oiled, so I won't be using them. With the input shaft and the other spindle bearing removed, I could finally see what was going on. The selector fork had fallen off, allowing the gears to fall out of mesh. It looks like the step drive pin was just a press fit into the fork, and it had come adrift. After a clean-up, I refitted it with some retainer and improvised a wire rivet to make sure it couldn't fall out again. With the bearings out, it was clear the small ones had seen better days. The big ones felt okay, but this seemed like a good opportunity to fit the new ones I've had waiting on the shelf for the last 5 years. In my case, the factory-fitted bearings are the standard 6206 deep groove type. Although perhaps not the best type for this application, I can't really complain, they've done sterling service. The replacements I'd be fitting are 7206 angular contact types, as they're a straight swap. A popular alternative is to fit taper races. These are a bit thicker, so the external covers and the internal spacers need modifying. When the one lathe in your one lathe workshop is out of action, that's easier said than done. Plus, I'm not totally sure how much benefit taper bearings actually bring to an inherently not rigid machine, or how much of my little motor's 500 watts they'd use with their large contact area and preload, or how to make sure their grease stays where it's supposed to be. That said, plenty of people use them and are happy with the result. I was telling a friend of mine what I was up to, and he lent me his puller kit over the weekend, which, with the addition of some lengths of all thread, made fairly light work of removing the spindle bearing. I know this is an unusual technique, but I didn't want to grip the spindle in the vise if I could help it. My little oven was already on, drying out my 3D printing silica gel, so there seemed no harm in warming up my new bearing a bit. It still took a bit of light hammer action to get it on the spindle though. The input shaft is plain, with no shoulders to locate the bearings. As a guide, the inner race needs to just clear the groove for the circlip. Although I had a set of new gears, I decided to stick with the old ones. They're not especially worn, and I reckon if they were going to fail, they'd have done so by now. For reference, the input gear sits in the space between the two ends of the larger output gear, with its larger end facing the chuck. Refitting the input shaft is a bit tricky, as it has to pass through the input gear, which in turn has to sit correctly relative to the output gear, whilst being held by the selector fork. Once in place, I pull the shaft into the chuck side bearing using a clamp. The main thing to remember when fitting any bearing is, as far as possible, to only press against the inner or outer race, to avoid transferring the load through the balls. Next came refitting the spindle. The bearing isn't a particularly tight fit, but it is prone to cross-locking. The chuck mounting flange is bigger than the bearing, so it can only be accessed through one of the holes. A few minutes of light tapping with a brass drift got the bearing in far enough to be able to push it the rest of the way by hand. The bearing on the other end was drawn into place with a box spanner and some threaded rod. with the drive pulley, a new belt and the lock nuts refitted, the repair was essentially complete. There were still the gubbins left in the tray that would need refitting. These bits were never particularly good and have worn considerably over the years. They will need further work before the lead screw drivetrain is anywhere near passable, but that would have to wait for another day, as I needed to finish the job I was on with at the start of this video. If anyone's interested in seeing me refurbish the drivetrain, leave me a note in the comments and I'll make sure the camera's rolling when I eventually get around to it. So in conclusion, it is possible to replace all the headstock bearings in a mini lathe without removing the headstock from the bed. It's also possible to replace the smaller of the two drive gears and repair the gear selector fork. But if the large gear or the gear selector arm need attention, then I think the headstock will need to come off. In truth, it probably would have been less fiddly if the headstock were removed in any case, but I wanted to see what was and wasn't possible. So that's it for this one. Thanks for watching, and I hope to see you next time.